There are a lot of notes and informational aspects to this chapter that you can use the PowerPoint notes on Blackboard to answer. I just wanted to take a few minutes and go through some of the math components. In order to be successful given a bunch of formulas, you really just have to know the formulas and know when to use them. So my suggestion to you is to memorize all the formulas that are listed. Put them on your note card for your test if you need to. And then when you read a problem, you can look to see what you're given. In this one, you're given 38.7 milliliters, which is a volume. You're given a unit of pressure, millimeters of mercury, and a temperature. Then you're asked for volume if the pressure changes and temperature is constant. It's important that you know that if a term remains constant, you don't have to include it in the calculations. So really, this formula involves my having two pressures and two volumes. So I'm going to plug those into Boyle's law and solve for the one I'm looking for. Notice temperature is nowhere in there because it's the same. You will round all your answers to significant figures on these as well. The next law is Charles' law, and it deals with volume and temperature. It's important that you know that this isn't temperature must be absolute, which means it's got to be in Kelvin. So any Celsius temperature must be converted. This particular example, you have a volume of CO2 at a temperature and a certain pressure. I asked for volume if the temperature changes to 27. Because pressure isn't mentioned, it is understood that it remains the same. So I write down what I know. Usually what I do if I'm looking at this for myself, I'll circle or underline or highlight all the numbers and the units of those values so you know how to match them up. And then you can look and match them up to a formula. In this one you have two pressures, given a volume, asked for a volume, and given temperatures. Notice pressure doesn't change, so I'm going to ignore it, and I'm going to use V and T, rearranging it to get your final answer there. The combined gas law is probably more useful than really knowing either Boyle's or Charles, because you can use this in place of the others. This allows you to change two variables instead of just one. If you're using this and the volume doesn't change, you would just leave it out. If the temperature doesn't change, just leave it out. If the pressure doesn't change, just leave it out, and you can get any of the gas laws that you would need. In this one, I have 5 times 10 to the first atmospheres, which is pressure, at a depth of 500 meters. The balloon is 5 liters. The temperature is 4 degrees Celsius, and then you're asked for the volume given the pressure at the surface of the air, of the water rather, and then the temperature. So I'm giving you two volumes, or asking for a volume rather, two pressures, two temperatures, and you solve. So I'm going to plug these into my equation, and your textbook rearranges it before it substitutes in. You don't have to do that, just whatever you're comfortable doing. But the mathematics wouldn't change. Notice all the units cancel out except the one for volume, which is the liter that you're given in the problem. Read through the facts here. I'm not going to spend a lot of time talking about the facts because I want you to focus on the math part when I'm here to help you. Ideal gas law is really important, PV equals nRT, and it's easy to pick out because in this one there's only one variable of each type, and all the others you have two pressures, two volumes, two temperatures, etc. Here I have only one, and it does introduce this idea of R, which is a constant that relates to the molar volume. More often than not, I use this first one, 0.082058. If you notice, the units are specific, so that means I have to have my volume in liters, my pressure in atmospheres in order to do this one. Alright, here you have a volume of nitrogen, pressure in atmospheres, temperature in Celsius, and I ask for the mass. None of the gas laws involve mass, but this one does involve moles. N is moles and PV equals nRT. So you can solve that equation for moles and then convert moles to grams, which we learned in early parts of the chapter. Notice you have to convert temperature to Kelvin every time. I solve for N, and I get 35.2 moles, so then I convert that using the atomic mass of nitrogen, and I get 986 grams. Density is also a good formula to know. You'll probably do a lab, depending on how the lab schedule has changed with all it's to know. That will help. M is molar mass, and that's equals dRT over P, where D is density in grams over liters. R is the constant, T is temperature in Kelvin, and P is pressure in atmospheres. So I want the density of a particular gas at 125 and 3.5. Because I know the identity of the gas, I can easily find its molar mass. So I know the molar mass, I know pressure, I know temperature, solving for density. And the volume is in liters of a gas, usually at densities. Then you see how that works out, grams over liters. This one is similar. It has a lot of information, and problems like this, I don't want you to get overwhelmed. Just take a minute and write down or circle or highlight whatever, all the different units, and especially including what you're asked for. So I'm given 500 milliliters, which is volume, millimeters mercury, which is pressure, temperature, and mass. I'm asking for molar mass. So the first part of this, you're really just solving your formula, M equals dRT over P. Density is grams over liters, so I take the mass given divided by the volume. That gives me density. R is constant. T is given. Pressure I do have to convert to atmospheres. And you just plug those into your value, those values into your formula, and you get a value, 114. The second half of this sort of brings in some things that you learned in the first part of the test, or the first test you took. Given the empirical formula, find the molecular formula. The empirical formula is C4H9, and if you multiply carbon's mass times 12 and add that to hydrogen's mass times 9, you get 57. So 57 is the mass of the simplest form, and the mass of the form we have is 114. So that means that the formula we have is twice as big, if you will, or twice as complex. So instead of C4H9, our formula is C8H18. My advice to you is to read through the next parts of these. When you have this stoichiometry question, you're really writing the equation. The only difference is now you're going to use your gas laws to get moles. So this one, you have a volume, and it wants to know what volume of CO2 is released when you have a temperature and pressure. So I'm going to figure out the number of moles of CO2 produced from the amount of of reactant given. Once I know moles, then I use that value to find your volume using the ideal gas law. Now, much of the next couple of slides is pretty common sense, so I'm going to stop with this here. The one thing I will suggest that you make sure you're comfortable doing or comfortable looking at is the van der Waals equation, which is at the very end, the real gases. You will not have to really use that for any practical purposes, but you will need to make sure that you understand that we're using this formula PV equals nRT under the assumption that certain behaviors happen. So make sure you read through the rest of the notes. I know I've zipped through these very quickly. You have them all on Blackboard. I just wanted to see this formula so you could see what I meant. It's much more complicated than the original. If you look at this, there's a correction for pressure and a correction for volume based upon the fact that gases do interact and they do exert pressures on one another, and you're given the values of A and B. I'm not asking you to memorize this formula, but again, I just wanted you to understand the reasoning behind it. The idea is pretty simple. gases become more like ideal when they have very large volumes initially and very high temperatures. So if the volume is large, the pressure is small, any changes you have over here would really be insignificant. I hope that helps you a little bit. I've already put some notes. Your notes are on Blackboard, and I put some videos I found on YouTube that had already been made that show you more step-by-step how to work out problems, since we didn't have that capability here. If you have any questions at all, please just let me know. Hope you guys have a good day.